Hello, today I'm going to tell you about dyes. This is the content that we are going to learn under this topic. Let's move to the next slide. William Henry Perkin is the first person in the year 1856 who discovered dyes. There are two types of dyes in the history: natural dyes and synthetic dyes. Natural dyes are where derived from nature. Synthetic dyes in the year 1856, an English chemist, as I told you, William Henry Perkin, accidentally discovered one of the first synthetic dyes. Dyes can be defined as substances that are capable of being fixed to the fabric like silk, wool, and cotton, and other substances such as paper and leather. There are important conditions for a compound to act as a dye, that is, presence of chromophore and presence of oxochrome. Always remember, a chromogene without an oxochrome can never act as a dye. So we can classify dyes into acidic and basic depending upon the nature of oxochrome present. Classification of dyes on the basis of structure and classification of dyes on the basis of mode of application. Classification of dyes on basis of structure. Nitro and nitroso, example picric acid; azo dyes, example methyl orange; triphenylmethane dyes, example crystal violet; panthenol dyes, example phenolphthalein; indigoid dyes, example indigo; thioindigoid, example thioindigo; and orthoquinone dyes, example acyl ring. Nitro and nitroso dye. The NO2 and N double bond O groups are chromophores in this class of dyes. Example picric acid and 1-nitroso-naphthalene 2-ol. Azo dyes. The azo dyes contain one or more azo, that is N double bond N group, as chromophores. The oxochrome present in these dyes are OH, SO3H, NH2, and R2. These are prepared in the following stages. Aromatic amine in presence of diazonization forms diazo salt. Diazo salt plus aromatic phenol or amine by the coupling reaction forms azo dye. Methyl orange is an example of azo dye. It contains SO3H group as an oxochrome. So, as it contains sulfonic acid, it is an acidic azo dye. Azo dyes are good example of ingrained dyes, that is, on the basis of mode of application. Here we can see the structure of methyl orange. Methyl orange is also called as dimethylamino azobenzene sulfonic acid. Here we are going to see the preparation of methyl orange. Step 1 includes diazotization of sulfonic acid, sulfalic acid, and nitrous acid. In ice-cold condition, we get the compound which is called as diazotized sulfonyl chloride. Further steps include the coupling of diazo compound or salt with dimethyl which gives methyl orange. It is generally isolated as a sodium salt, so it is further reacted with NaOH to give the formation of the sodium salt, which is used as dye. We can see methyl orange is yellow in alkaline, that is in basic solution, and it is red in acidic solution. Due to p-quinate, methyl orange shows the red color in acidic medium. Here we can see some properties and uses of methyl orange. Let's move to the further slide. Anthraquinone dyes. Paraquinate is a chromophore present in this. In this dyes, p-quinate group is used between the two other benzene ring. Acyl ring is a good example of anthraquinone. It is 1,2-dihydroxyanthraquinone. Acyl ring, it is the name which derives from the plant which has red roots of madder and plant having yellow flowers. Small yellow flowers and red roots formerly an important source of a dye. Preparation of acyl ring. Step 1. When phthalic anhydride is treated with benzene in presence of AlCl3 to form O-benzyl benzoic acid, which is further treated with concentrated H2SO4 to form anthraquinone. 2. Sulfonation of anthraquinone by fuming H2SO4 at 160 to 180 degrees Celsius. When anthraquinone is heated with fuming sulfuric acid at 160 to 180 degrees Celsius, it forms anthraquinone 2-sulfonic acid. The step 3 involves formation of azylrene from anthraquinone 2-sulfonic acid. When anthraquinone 2-sulfonic acid is fused with NaOH in presence of potassium chlorate at 200 degrees Celsius under pressure and followed by acidification by dilute H2SO4 to form azylrene, that is 1,2-dihydroxyanthraquinone. In this way, we can achieve azylrene. Here we can see some properties and uses of alizarin. Let's move to the next slide. Triphenyl methane dye. Triphenyl methane dyes can be identified by common structural representation as shown below. The central C atom is joined to the 3 aromatic rings, from which one is p-quinide ring and 2 are benzene rings. In this dye, quinide group is a chromophore. The example of this class of dyes are crystal violet. Here is a structure of crystal violet and its properties and uses. As we can see, the central C atom is attached with the one p-quinide ring and the 2 benzene aromatic rings. Phthalate dyes formed from the phthalic anhydride and phenols in presence of dehydrating agent like zinc chloride or concentrated H2SO4. The term phthalate is used to represent the dyes formed from the phthalic anhydride and phenols. The characteristic chromophore present in these dyes are triphenyl methyl structure. Example is phenolphthalein dye. Indigoid dyes. Indigo dye is a dye for a cotton yarn which is mainly for the production of denim clothes for blue jeans. Natural indigo formed from the plants of Indigofera group is oldest known dye. Indigoid dyes contain the group as chromophore. Thioindigoid dyes. Thioindigo dye is similar to indigo but differs only in one respect, that in the place of 2 NH group there are 2 S atoms. Thioindigo is used to dye cotton, wool and polyester. For example, thioindigo dye. Classification of dyes on the basis of mode of application. Direct dyes, example indigo and lichens. Indirect dyes, azylrene. Ingrained dyes, pararet. Bad dyes, indigo. Dispersed dyes, Celatone fast blue. Direct dyes. This can be applied to a fabric by a direct immersion in aqueous solution of dyes. Ingrained dyes. These are also called as developed dyes because the chemical reaction resulting in the formation of dyes. Bad dyes. These dyes are insoluble in water on reaction, which has great affinity for cotton and other cellulose fiber. Application of dyes. Some of applications include textile industries. Dyes are used to color cloth in textile industries. Paper and printing. Dyes are used to color paper and printing inks. Food and beverages. Used in coloring of food like soft drinks, candies and etc. Biochemical, biomedical and research. Used in biological staining, immunohistochemistry and etc. Plastic and polymers. Used in fiber optic coloring and also coloration of plastic and polymers. So, here we completed our topic dyes. I hope you all understood. Thank you so much.